Windows PC. You've got your system facilities gauges here. You've got your kind of operational gauges here. So like your vacuum, your substrate vacuum, your contact vacuum, your mass vacuum, all that stuff that you need for your process. Let's see. So we can just go through Lowe's getting set up first. So you've got your kind of process area here, microscopes. So if you're going to load a mask and a chuck, basically what you do, you have these 3 thumb screws here. And actually, I think on the new systems, these have been replaced by automatic air cylinders. So it's a little easier, but basically the same thing. So that's the mask holder, and your mask is just held in by vacuum. Vacuum button is right here.
Gotcha.
Okay. And then they aren't using the clamps, but there are mechanical clamps here to hold the mask in place in case of loss of vacuum, right? So. And then when you switch mask holders, it's just a quick disconnect. I'll remove the mask now. And then to change the chuck, actually let me put this in so we can see what's going on. So to change the chuck, it's pretty simple. The chuck just slides out and you do the quick disconnects. Yeah. The chuck just sits on this tray, and then you just want to make sure you just line it up on the pins. Yeah. And then that's it. You're done. So put this guy back in. And then this thing rotates, right? So that's how you set the mask data. So what we'll do is you pick up the targets, and then once they're lined up, you just plot them in place.
Interesting.
Yeah. So those are the mask targets. So that's doing the tooling change. The microscopes have zoom settings on them, so and focus. So it's manual focus and manual zoom on top of it. Okay. So you just they're detented, so you can adjust them from 1 up to 4, and each setting has a little detent position that you adjust it in, and you need that detent because for each setting there's a calibration for how many microns per pixel on the screen for doing the auto alignment.
Okay.
And so it just if you put it in between, then it's going to be between the calibration settings that are stored in the setting. Let's see. So the next step, if you get done loading your tooling, is to load in which process you want. And this is the process editor. So a couple of things here. We just talked about the magnification. So you have to tell it what setting you're going to use in your recipe. Otherwise, the calibration will be wrong. This is the vision file, and we'll get into that. But that's basically the pattern recognition for looking at the targets. So you have to tell the process which pattern recognition file you're going to use. You can set your different exposure types between proximity to vacuum contact. You set your alignment gap, your exposure gap. This has an LED light source on it, so you set the dose for that exposure here and your intensity as well. Sorry?
Oh, so that's right, because for the LEDs, you can change the intensity.
You can, all the way down to 1.
Right, go low.
And then up here, you set the type of alignment, whether you're doing top or bottom alignment. You can set the alignment accuracy that the machine will try and achieve before it will do the exposure. And you can set offsets to your alignment if you want. And then you have to tell it on this tool what the separation distance is between the two mask alignment marks.
Okay.
And you have to do that so that it knows the theta adjustment to make when it calculates a misalignment.
Okay.
And the reason for that is the optics are controlled by a joystick and they're motorized, but for the x-axis there's no encoder, so it doesn't know how far apart these are. Okay, so that's the recipe.
And that would just be off your your mask file,
Yes.
basically, right? Okay. So
Yeah,
just
so you
throw in
you type in your mask ID here, and enter in your separation.
That's okay.
And
That
save
makes sense.
it. That's it.
Right. Makes sense.
And for that process, it would be forever that.
Gotcha.
So then, once we're done with our process, we save it. And you can see it's just a Windows interface.
Right.
You can save as many files as you want. And then you have to, once you've edited your process, that window is just an editor. So you have to actually tell it that we're going to run this process. So you open that process and say, now we're going to run. And I think that's loaded. Okay. And so now to run, you have two modes that you can start in. You can do an alignment or you can do a first mask. So the first mask is just going to level the wafer, bring it up to the mask, move it to a saved offset position, and expose. And if you do an alignment, then what it'll do is it'll bring it up and move it to that same offset position, but then it will enable the joystick. And at that point, you can move the wafer around. And once you get the fiducials into the field of view, if they don't come up in the field of view for some reason, you'll be able to just switch to auto alignment. So we'll do that right now. So let's start. I'm going to leave this up. Normally this would be down, but I'll leave it up so you can see what's going on. So it just gives us a couple of questions. And it slides the tooling out. There's already a wafer on there, so it's already there. So once you load the wafer, then it'll just tell you to press the cycle button. And when you do that, it vacuums the wafer down and then slides that guy in. So that's, I don't know if you can see that, but that's the leveling pins that come in.
Oh, okay.
So there's 3 stainless steel balls that are now sandwiched between the mask and the wafer, and that sets the gap. So it's done leveling, and so now it comes up and it's moving to whatever position is saved here. I don't know where it is. I might have to move it to. Okay, so now it's enabled the joystick, and I think the targets are over here. Yeah. There's one. Yeah. Now, Raynard, their targets, they do a manual align for some reason. I don't know why they're doing it that way, but these targets are really, I don't know if you know anything about auto alignment machines.
A little bit.
But these targets are not ideal for auto alignment because they overlap, and so that confuses the computer between which one is which. Right. So ideally, you want them to be like one being completely around the other one with no overlapping lines, or so it can see the edges.
4 boxes and a cross or something.
Something like that, yeah.
That's kind of what that is.
Right. And so what I did here earlier today is I trained these targets so that it's going to align this corner to this corner so that they don't overlap.
So they'll just be stacked.
They'll be stacked.
Okay, yeah.
But it'll show the process.
Right.
You'll get the idea. All right, so they're here, so now we switch to auto align. So it does a quick alignment first,
Right.
and then it'll do the fine alignment. And what it's trying to do is, here's the misalignment. As soon as these are below the setting, which is like
Right.
1.5 microns right now, then it will do the exposure.
Okay.
And I don't know what, I guess they have it set for 100 millijoules, so it's, you can see it's counting that up. And when it's done, it brings the wafer back.
Oh, wait, so it just exposed right now?
Yeah.
Oh.
Yeah. This is the 365 nanometer LED. You almost can't see the light. There's very little visible light.
Right. Yeah, the arc lamps. It's like.
Right.
It's like.
Right. There's a lot of visible light
A lot
there.
of visible light.
Not much visible light here.
Oh, that's really cool.
Yeah. I mean, you can see it. If I turn it on, you'll be able to see it.
And there's like, so maybe I'm just thinking of tools I've used that have like a big kind of like light guide, right? Light height.
Yep.
And it seems like it's really close to the wafer.
Yep.
But,
So we don't do it that way.
okay.
Just to keep things a little simpler, less expensive, less complicated, we like to just fix the light source in place.
Right.
So all the optical components are fixed, they don't move, nothing's gonna change,
Right.
everything's good. So then we just basically move the lights, the microscopes out of the way.
Right.
And you can see the lens is right here.
Okay.
We just expose
It
it.
just switched through.
Yeah.
Interesting.
And in some ways, it probably doesn't make much of a difference either way, but
Right.
we like to think that it's a little bit better to keep things farther away, because when you have a lens surface, you're going to have some scattering onto that surface.
Right.
And the farther away you are from that scattering, the narrower that angle is.
Right.
For just the scattered light part. I'm not talking about the direct beam.
Right.
So I don't know if that makes much of a difference, but we've printed with this exact light source design here. We've printed down to 0.4 micron.
Okay.
So it works really well. So that's the process. Is there anything in particular you want to?
I guess to just look at the. I mean, it's contact around
Yeah.
Okay, so you can play with your brightness and
Yeah.
stuff
So
on
here we'll just do another. So basically, when it comes out, you load another wafer
Right.
and press the button, and it goes back in. But yeah, I can show you how we play with the brightness. So basically, what these exposure and gain settings are inside the cameras. Okay, so we have LEDs that shine coaxial light into the microscopes, but we don't vary that lighting. So the way we vary what the camera sees is just by changing the camera settings.
Gotcha. Okay, interesting.
Yeah, and so these settings here are stored. Actually, when you change them, they're immediately stored in the process file.
Okay.
So whatever you end up with on your last wafer of the process, that's going to be saved for next time.
Okay.
So if you wanted to change get a little less light, you just dial these down, and you got less light.
Okay.
And I typically tell customers to change the expose time. If they need more light, change the expose time first, because when you increase gain, you're introducing more noise into the image. So, but you can see it's a pretty clean image.
Yeah.
And it would actually be even cleaner and sharper. These optics are long working distance optics with prism assemblies attached to the end.
Gotcha.
Because they need to get really close together for their small wafers.
Right.
Normally, we have on here, Mitutoyo infinity corrected objectives that are very high resolution. This would be like crystal clear.
Okay.
little bit better objective on it.
Gotcha.
But it's still pretty good.
Yeah. What's the live video?
Yeah.
Is it just
So that if you turn that off, now it's just a frozen image.
Oh, okay. So you can
Yeah.
just kind of lock it in.
Yeah. So usually you use that when you're training, and we'll go through the training.
Oh, okay.
But you know, live video now it's live. So I can tell you about it. These two buttons here. This joystick does two things. It can control the chuck position for doing alignment. It can also control the microscope position.
Right.
So right now it's controlling the chuck. So you know, if I move this around,
Right.
I'm adjusting the wafer. And I'll get those into position. Okay, so that's the wafer. But now if I were to change to this, now I'm moving the microscopes.
Right.
With the same joystick, right? So just kind of
Does the joystick have any functionality? Like, can you switch it on the joystick? Or no, you have to click on the...
to switch between the chuck and the optics, you have to click these buttons. The joystick does have functionality. So if you're doing a manual alignment, let's say I'm doing a manual alignment, so I'll do this.
like a fast or...
Yeah, so if I hit the space bar, now I've got chuck speed is slow, and now I'm doing very, very, very fine.
Okay. Oh,
alignment.
okay, great.
And if I want to see really what's going on, you know, I can get in there and
Nice.
get this really lined up. I hate doing alignment, but
I mean, I think the auto alignment is so
yeah, it's so good.
nice to have.
Right.
It's like, wow.
So anyway, so once you get this aligned, now what you do, you have the button on the chuck. So now you press the button, and it says press cycle to expose. What it does when you press that button is it moves from your alignment gap to your exposure gap. So
Or,
now you're
or exposure.
whatever your
yeah.
process is, you're now there.
Right, right.
And now if you like it, you can press the button.
Cycle.
So if I press the button here, it's happy. It moves those out of the way, and it's going to turn that.
It's just
Wow. Yeah.
Cool.
So you have two modes. The space bar just toggles back and forth.
Okay.
Yeah. So if you ever bring the wafer up and you're doing alignment and it's like seems like it's not moving, it's probably in slow mode. You have to just toggle it back and forth.
Gotcha.
Yeah.
And then if you click the button again, like it's in, if you're doing contact, it's like in contact, you're like, okay, no wait. Click it again and when it's
That's
separate,
right.
and then you're like, okay, do a little more to the left.
Yeah.
Boom.
You just click it and it goes back into
You could test, yeah, you can kind of
Yeah. Yeah. Gotcha. So that's that. Do you want to show you the training?
Sure. Yeah.
Okay.
Great.
So once you're done with the process, you know, this is just in a loop, right? So
Right.
it's always telling you to load the next substrate. So to get out of that loop, you just say abort, and then it's done. So it's all complete.
So say you want to, is that abort lit like
Yes.
a lot of the time?
Yeah,
or-
you can abort, like when we got the wafer up there,
Right.
you can abort from there.
Right. I just because some other tool, like the tool we have, it's like some processes, like once they're going, you have to like go through like 3 or 4 steps before you can like no, okay, abort.
Right.
It's kind of
So let me,
silly sometimes. It feels like.
yeah, so here I'll show you when it comes up. I mean, so let's say you're running. So first when you press run, it'll give you a chance to stop. So you have a
Right.
chance to either proceed or stop.
Right.
Oftentimes you'll press run, you're like, oh shoot, I forgot.
I gotta get. Yeah.
Okay, so you can stop here.
Gotcha.
But if you proceed from here,
Okay, yeah, it's lit up.
it's lit up. And so you have it there, but most of the time at this point, you're probably going to continue, but you could stop.
Right.
But from this point on, if we say okay, I don't think you can abort until it actually gets the wafer up to the mask.
Gotcha.
I mean, it's lit. Maybe you can abort. I can try it.
Can you talk about the online, is that the wedge?
Yes.
Edge compensation thing?
Yeah, that's what it's doing right now.
Okay.
So it brings those three spacers in.
Right.
Okay, and then what happens is, and I'll show you on the chuck, but it basically flows nitrogen under the chuck, and then the chuck surface can flow
Okay.
like this. And so when it contacts those three spacers, the surface will planarize to the mass with the three spacers, and then lock itself in place.
Okay, interesting. Okay, cool.
Yeah. And the way we sense the height is once those three spacers touch, there's a downward force on the chuck.
Okay.
And we're measuring the pressure of that nitrogen that's flowing.
Okay.
And so that pressure will increase, and we say, okay, now we're there.
Do you see is there like any, so you actually do have bearings on the top of the wafer right now? Like, is it contacting the wafer?
Yes, those three balls, there's three stainless steel balls, those 3 points touch the wafer.
Okay. And you don't see any, like just thinking aloud, like, don't see any weird issues from that?
No. No, I mean, this is,
I mean, I guess you're
in most contact aligners, this is how it's done. Like
Okay.
EVG, SUS, they all use three spacers.
Okay.
The other way of doing it is to, and you can do it, it's just a setting in the process recipe. You say, don't level with the spacers, and then it will just planarize directly to the mass.
Okay, okay. I think that's what I've seen before, is it just goes right.
So you have the option to do that.
Okay.
So yeah, so here you could abort, abort the wafer and then just pull it back out. So let's see what else. Oh, we were going to talk about the vision. So let's do that. Small abort this. So now, if I was going to train these targets, we have this little V with the goggles is our vision screen. And so here's where it shows you our file that we have loaded in the process. It's also showed down here. It shows your process file, it shows our vision file. Okay, so this is our vision file that's loaded. If I want to load a new one, I just hit load and load whatever else. If I want to make a new one, I just hit save and type a new name. Okay. So, and then we have these buttons down here that you can see left, right, mask wafer, okay, and also top, bottom. Top is for the upper microscopes, bottom is for the lower microscopes. So if I wanted to train the left mask on the top microscope, I just select these buttons here, and I tell it to untrain the model, edit the area, and then I'm going to use blob. And blob means that whatever it finds, it's going to use the centroid of that area to find the center. If I don't use blob, then I manually drag across the center where I want it. Okay. So if I use blob, I move my box to wherever I want, and you can just drag this box around. You can rotate it, change the shape, you can do all kinds of stuff to it to match whatever you're doing. And it doesn't have to be fit directly around. It could be, whatever. And I'll test it by telling it to find the center. And let's take a look and see what it's got. It doesn't look very good to me. It's finding some weird stuff. So I might increase the lighting there. And test it again. There we go. That looks better. So now it's finding our nice clean image. It's got the center. And I just train. Now it's fine. Okay. So you do that for both sides. So I would just select the right side now. Untrain. Edit my area. Drag it over here. Find the center of mass. Cool. That's it. Cool. And then the next thing you have to do is the wafer. So we would then go over to the maintenance screen.
Could you, say you don't have like a good alignment mark,
Yeah.
and you're like, maybe there's like an edge or a corner.
So
Does it have to find?
you
Does that
can
work with the centering kind of process?
So the answer is you can. It's flexible enough that you can try.
Okay.
I mean, there's probably a lot of variables.
Right.
But you can see it'll find whatever you tell it to find.
Okay.
And the only caveat to like using random image, things that are on your wafer is when they're aligned, you don't want them overlapping. Right? So that's a problem. And if you're using like a corner of some square, those kinds of marks can often get confused with other corners of other squares.
Okay.
So it's just going to have to be like your situation, like whether you have a unique corner square that's not going to get confused with something else in the image. Yeah. Ideally, the best marks are unique on the field of view and separate from each other completely.
Just thinking of like older masks that we
Yeah.
that maybe.
I mean,
but you could always you
can always do a manual
or you
alignment,
could always do manual.
and you can always play around with it and try it. If it doesn't work, it doesn't work.
Right.
So if we were going to now bring the wafer in, we just come to this maintenance screen and we just tell it to load the wafer. So we're doing this outside of the normal run process. Because the normal run process just has its normal sequence and it goes and goes and goes and goes. So it just tells us to load the wafer. We bring it in. And so what it's going to do now is it's going to do the planarization again, and it's going to bring the wafer to the alignment gap, but then that's it. Like, it's not going to go on and expose or do anything. So we're only going to use this to train the target. Okay. So we turn on live video because it's just a dead image. And we have to enable the joystick here. And now we have to go find our find anything. It's not moving. It almost looks like it's stuck.
Yeah.
Let me try and level it again and see what's going on. So this maintenance screen has like, a few macros that you use, like for loading, unloading. You can move between the exposure gap and the alignment gap. You can obviously level the chuck here. So let's see if this is any better.
Logging slow.
Oh, you got me. Yeah.
I was like, it looks like it's trying to move.
It's trying to move.
Oh, okay, yeah. It's
Pilot error. Okay, so now we've got our wafer, and we just come back here and we do the same thing with wafers now. So I just select wafer. Okay, right? And so to train the right wafer, let's get it clear, and we just do the same thing. Find center of mass, train the model. There we go. And on the left side, that's pretty bright. Let's turn that down a little.
And then did you just like offset it when we did to get it to go like top and bottom?
Oh yeah, so what I did there, and I'll show you what I did. I didn't use blob, so let me go to left here. And untrain the model, edit area. Okay, so I didn't use blob. I bring in the cross. brought my thing to there, and I brought my cross to there, and I zoom in, and I just brought that like that.
Okay.
Okay?
Oh, so you could go like find the center here, and this crosses your
I could say
point.
this is my pattern,
right.
and I say
Here's
this
where-
is my alignment mark, or this is my center. So
Oh, okay.
if I make my mask mark, wherever it finds my mask center, it's going to put it to here.
Gotcha.
So it's
Oh,
going
okay,
to
cool.
take whatever you tell it is quote unquote the center,
Right.
and line those up.
Put it to where you. Gotcha. Okay.
Yeah.
Cool.
So it's kind of flexible in that
Right.
in that regard. So now if I train it, you'll be able to see it. See?
And it goes.
That's-
Now it goes. Okay.
So if this mask was trained, so if we go to mask,
But now it's going to go
Say-
center of the mask to that.
Right.
Gotcha.
so if I say acquire and find here on the mask, it's going to line that center up with that corner.
Gotcha. Okay. Okay. Cool. That's nice.
Yeah.
How much gap do you like, right? Like, say you have, say that wafer diamond's a little bit bigger. You have like 10 microns. Like, what's the?
Oh, for the overlap,
because you don't want them to
right.
completely cover.
So it depends on how big the marks are overall,
Right. Okay.
right? But when we do it, so I can draw it. Can I draw on your?
I have a notebook too.
Yeah. So our typical alignment marks,
That's fine.
are like, we'll have like a star shape here, like this, and this might be 30 microns,
Okay.
and then we'll have a chevron around it, like this, and this might be like 150 microns. So you can see there's quite a bit of,
Decent.
not only that, but there's a lot of space in here. So that means when this mark is like not aligned, it doesn't have a large chance of being completely obscured.
Okay.
And we have a PDF I can send you of what that is. It shows marks. So yeah, so now that we've got this all trained, we would just save it and put it whatever file name you want. And then when you come in here, you would then just tell it to load that file.
Okay.
And save the process, and then you're good to go.
That's your process file.
That's your process file. And all of the process files, so if you come in here, on the C drive under Align 800, you have, this is basically everything to do with the tool. So if you back up this folder, you're good to go. And if you come down to the process folder, these are all your processes. And you can, whoops, that's not what I want to do. Select a program. Okay. So if you open them in Notepad, they're all right
It's
there.
all
So you can see
what's
what's in there. Yeah. And what else? All of the machine settings are in this align INI file. So this is like all the settings for the machine. And the other good thing about this computer is there's really nothing special about it. So there's no hardware in here that's like custom. You could run this tool off of a laptop. Like if you unplug the Ethernet and just plug in your laptop, you can run the tool off of it. So, if the computer dies or you want to upgrade the computer later or whatever, it's nothing to do.
Okay.
People are always worried about computers going out of date.
Right.
Something breaks 10 years from now, you can't get the motherboard, or,
Right.
you don't have to worry about anything like
Yeah.
that. So,
There's a lot of tools like that, though.
Yeah, there are. There are. Yeah, so let's see, what else can we talk about?
Can you just run through like maybe a more manual? Because I actually really like that maintenance or res setting function where you can just kind of like you can kind of do it more.
Yeah.
That's one question too, and then also, do you have any type of when you're doing like a dose matrix? Is there any like settings for that maybe, or is that just kind of maybe manually?
We were just talking about that. There is something in the process file. I'll be honest with you, I've never used it, so I don't know if it works or how it works. We could test it out here. Maybe we'll break the machine. So let's say you wanted to do a gap, like an exposure gap matrix. Okay. You could do that here, where if you had a quarter mask kind of thing, you could do that. But it's kind of a hassle because you have to bring it out, rotate the wafer, put it back in. It's almost easier, I think, to just set up 4 separate process recipes. Yeah. There's no dose matrix in this particular code. We could put one in if it was of interest to you guys, but for the LED light source, there's no dose matrix that we've set up in here. We only have the exposure gap matrix. We used to have a dose matrix, but when we implemented the LED, we didn't do it because nobody had really ever used it. But you know, if something you say I'm going to use all the time, and I really want it, we'll do it. Like, we can do it, no problem.
Yeah, I mean, it's not like you save a ton of time, like you said, you can pull it out.
Right. Yeah, but if you're going to do it if you're going to do matrices like every other day, you might want something that
Right.
Yeah. Because what you could do is, have like a shadow mask on top of your mask.
So that
you could easily just rotate while leaving the wafer in.
Yeah, that's kind of what like PPG does. They have like a matrix run, and you just kind of have this little disc, maybe a quarter around.
So one thing you could do on this, here, I'll cut this out. Let's stuff this in there. Okay. One thing you could do is in this manual screen, we could bring the wafer up to the gap.
Right.
And then here at the LED light source, you can control it from here.
Okay.
So we could just say, okay, I want to do a dose of 50. And say okay. And then just hit start right here. And do the exposure.
Okay.
And then you can rotate your little shadow mask.
Right.
Do it again.
Okay, so you can kind of do it manually.
Yeah. Because you have manual control of the light source.
Okay, cool.
Yeah. Actually, so this is a little bit different. This is the first generation LED light source. The new one has a separate controller that sits down here on this shelf.
Okay.
So it's basically the same screen.
And then or could you do it manually, like in your process too? Like you have, like there's a timed expose button over there.
So that timed expose is only that timed expose is only active when you have a mercury arc lamp.
Gotcha.
If you have an LED, all the control is from here. Yeah.
Gotcha. Okay. But like you said, you could basically go through like the macros, bring your wafer up.
Yeah. So we can do it. We'll do it right now. So I'll say load wafer, and so it would bring it out, which it just did, and now it's going to say load the substrate. So I load it. Okay. So now it's loaded. So right now it comes up at the alignment gap. So now we can say, okay, I'm going to move to my exposure gap. Okay, so it's at the exposure gap. And now we can go up here.
You can just go, okay, start. Yeah, okay.
So I'm at 50, so I can say start. Now it's going to do a 50 dose. Okay.
And then you can open the light shield.
Open the light shield.
Oh, this okay. This is perfect.
Now
Move
move
your
my
little
thing. Close the light shield.
Change it up there or
Yep.
wherever it's at. Okay, yeah, that's very good.
Yeah. And I can go change that. Right.
Okay, cool. Yeah, I really like the manual. Sometimes that comes.
Right. I'm trying to get my software engineer to make the whole, like even the run mode more asynchronous. So like, you know, you could like be working in this manual screen and then switch back to the run mode and just in the middle start auto alignment.
Right.
So he's working on that.
Right.
But yeah, it'd be nice if the whole thing was just totally open to wherever you are, you just start.
Go. Right.
So that'll be in a later version. So. Yeah. And then do you guys are doing backside, right?
I think we're. So that's one of those things that we're like. I think we're trying to have it so we can at least retrofit it for sure.
Okay.
If it comes up. Currently, we're not doing any backside.
Okay.
That's.
So if you do,
it's thrown around.
the backside cameras are right underneath, and
Okay.
you can see they come in from the side,
Right.
and they're joystick controlled as well, except for the Y-axis is manually adjusted with these
Okay.
little knobs.
Oh, and they're individually.
Yes.
Oh, cool.
Yeah. Yeah. They're totally, the two backside are totally separate, independent of each other.
Cool.
Yeah. What else can I show you? Let's see. I mean, you've got, you know, your status of all your sensors is right here.
Right.
Oh, here's the joystick. I guess it's not active right now, but this tells you the status of the joystick. Fast or slow. Yeah.
Interlocks.
Yeah.
Other stuff.
All the sensors are here.
Right.
So these are the sensors. What are these? Oh, these are the outputs.
Okay.
These are the outputs. The status of the outputs. What else?
Is your vacuum contact, is that, so it's just like the chuck has like a
Rubber seal.
and just like this.
Yeah, the rubber seal comes up and makes contact with the mask, and then we go into a soft contact, and then turn on the vacuum pressure. So it just kind of pulls them together. Yeah. And then there's a hard contact mode as well, where that just blows nitrogen behind the wafer to press it up against the mask. Yeah. Yeah.
Very straightforward.
Yeah.
Can you change your alignment gap kind of
Yeah.
on the fly?
Not on the fly. The alignment gap is in the process setting.
Okay.
So when you're messing around in this screen over here, it's going to go, when you say alignment gap, it's going to go to whatever is loaded in the
Right.
process file.
Okay.
So whatever you have set here, and if that's loaded in here, that's what you're going to get.
Okay.
So you can change it on the fly. Actually, I shouldn't say you can. If you're in this screen and you want a different alignment gap, you can go change
Go
your
to
recipe,
change it.
it, load the recipe, and then hit the alignment gap button, and it'll go to that new gap.
Okay, yeah.
But during a run,
Right. I'm just thinking like first time,
yeah,
just setting up your process, and you're
Yeah.
like, okay,
yeah, you're messing around in here.
messing
you
around,
can-
trying to.
You can do that.
I think that's.
Yeah, there's not that much to it.
Yeah, I think we covered a lot.
Over here, we have, getting into some of the more like lower level stuff. So you have a bunch of motor axes on this tool.
Right.
And so here, this screen gives you individual control of those motors. So we have them labeled by its letter,
Okay.
and you can just step through them,
Oh, great.
right? And then they have all their velocity and acceleration settings.
Okay.
You can give them direction. You can say like, I want a relative move of
here.
like 40 microns. It's all in
Oh, okay.
microns,
Okay.
except for theta. Theta's in radians.
Okay. Okay.
But yeah, you got to be a little careful because if you give it a big number or you tell it someplace where it can't go,
Right.
it'll just go.
Try that. Now I'm trying to think like if our equipment guys, but I think they were pretty. They didn't have too many questions since everything is pretty open. Like it's not.
Yeah.
It's,
Yeah.
You guys are pretty like, yeah, here's all the stuff. Like there's no.
Yeah. And then
This is cool though. I like this.
yeah, you can password protect access to all these things.
Tier
Yeah.
tier the access.
Yeah. So if you come over here, everything's password protected.
Right.
So you can edit them. You can set the levels for the different users. And then your operators wouldn't have access to this stuff.
Right.
So hopefully they wouldn't be able to break it. To set up the tool, you just when the tool first comes up, you have to log in, and then you just come here and initialize the hardware. So you're going to initialize the hardware. And just say yes. And we'll just go through this initialization routine. It's usually pretty quick. It's going to take longer now because our z-axis is all the way up. It's going to drive down real slow.
Mask, pretty straightforward. Sample holder.
Yeah, so here you can see X, Y, W, W is theta, X and Y are the X, Y of the chuck, Z is the Z of the chuck, O1 is the fore-aft axis of the microscope, and then F2 and F3 are the focus axes of the bottom objects. That's it. That's all it needs to initialize. That's done. So there you go.
For one last thing, I think. Intensity checks.
Yeah. So to do an intensity check, you take your meter, you would open the light shield and stick it in there, close the light shield.
That's right. Everything's through.
Turn it on like that. That's cool.
Yeah.
And I'll show you how to do that. So to do it, what you do is you put it in test mode.
Okay. Now it goes to.
And you put it into, instead of intensity mode, you put it into current mode. So it's only driving a constant current.
Okay.
And then we usually like to calibrate it at like 90%.
Okay.
So we say 90%. We turn it on. Okay. We wait till it stabilizes.
Right.
And then we go to calibration. We go to calibration. Oh, you know what? I might need to. This has been running for probably days or weeks. Sometimes, in order to calibrate it, we need to turn it off first. Yeah,
Okay,
so
that's okay.
I can do that. No, it just takes.
Oh yes, that's an LED. Oh, you were kidding.
From the other side.
And then for the dose, so would the calibration be, you have your little sensor.
So here we do it again. We're in test mode, current mode, set it to 90. Okay, and then we turn it on. So that brings up the calibration screen. Now we have our reader in there,
right.
and say it's reading 20.
Right.
We would just go in here
Put that.
and type that in. Right here.
Gotcha.
Type in 20, and I guess it's an 18. I don't want to mess up their calibration. Okay. Anyway, so then I hit the calibrate button.
And now
Now it's calibrated. Yeah. And then you just go back to the main screen, and now you can put it back, you can turn it off. There we go. So it's off, and now we put it back in intensity mode and back in dose mode.
Okay, cool.
Yeah.
Cool. This is like the easiest intensity I've ever control I've ever seen.
Yeah. Piece of cake. And in fact, you don't even have to put it back in intensity and dose mode. If you forget to do that, the computer
When you
will do
run
it.
auto.
It will do it. Yeah. Yeah, there's a, the light source is just plugged into the computer through a USB port. That's it. Yeah, that's kind of it.
Yeah.
Oh, I didn't show you one other thing. So when you first, after you initialize the system, you know, the optics are going to be back out of the way, and you load your process file, and then to bring the optics in to make sure you can see your microscope, you press this button, and this will bring it to wherever you have saved that optics position. And that optics position is saved when you hit the save current optics button. It saves it into whatever process file is loaded.
Okay, nice, easy. Yeah. Okay.
So it just, you save it, and then the next time you bring up that process file,
It goes. It knows where to go.
pretty much at the right spot. But we didn't come back, so.
And is that the same with
We're
the?
supposed to be.
Is that the same with? So if you just clicked the wafer and saved it, would it know
Yes,
wafer
so
position as
actually
well?
it's this button.
Chuck setting. Gotcha.
This, when you press this button, it saves that wafer position
Okay.
also into the process file.
Gotcha. Yeah.
So you get your wafer lined up targets, so they
Right.
come in the field of view, hit that button, all the rest of your wafers are
And it should just be super. Yeah.
Yep.
Yeah.
It's pretty like simple relatively. I mean, there's
Right.
there's a lot of different features, but
Right.
it's pretty easy to operate.
Well, no, I think it seems pretty refined in like a lot of the pain points, which is nice.
Yeah, we've heard all about the pain points over the years. I've been with OAI for 21 years, so I've heard all the pain points.
Yeah. Yeah. Well, you run it long enough, and you're like the littlest thing. You're like,
Yes.
Go here.
Yes.
Cool. There's a lot. Yeah, I think that's pretty much.
Yeah. Yeah. It's pretty straightforward.
Cool. Thank you.